Hi all, welcome to Network Path. And in this video, we will be talking about distance vector routing protocol. So most routing protocols fall into two big families, distance vector and link state. And in this video, we'll focus on distance vector. We'll save link state for later. Now the foundation of distance vector algorithm comes from the work of Bellman and Ford. These were two scientists. And that is why this distance vector routing protocol is called Bellman-Ford algorithm as well. And there's a protocol EIGRP as well, which has a different sort of algorithm, which was developed by someone else. We'll talk about EIGRP in detail in different video. But why we call it distance vector? That's the first question. It is because routes are advertised or shared as pair of distance and direction. You, on the screen, you can see I've drawn a vector. Okay, a vector in physics is something that has uh, you know uh, magnitude and direction. These two are the components of a vector. So if you are telling about direction, you can tell about, if you're telling someone about some place, you will tell that person direction and distance as well, so you are conveying a vector. Okay, distance means the metric here, for example the number of hops, right? And direction means what is the next router, which interface do I have to route this packet, right? Hope I'm clear. Now, here's an example, okay? Let's say destination A is 5 hops away and you can get there through router X. Let me draw this. If these are some routers connected with each other, and if this router has got some packet and it is a network that is connected on this router, let's say X and this is Y. So Y has to decide through which interface it has to exchange that packet. Let's say if this is connected with this router Z as well. So it has two paths, right? If some packet has been sent from here for this network, what it will do, it has two paths. It can send it this path and send it through this path as well. So it has to have two differentiating factors. So one is the direction and second is the cost or the distance. And if I directly look at the image, we can see that this distance is lower. But for just for the example, let's say the cost is 10 and cost for this path is 15. So definitely router Y will choose this interface, right? So that's the essence of a distance vector. Each router learns routes from its neighbors. Okay, neighbors are the routers that are connected, okay, directly connected. They could be somewhat away, but they are connected through a logical link. Let me explain this to you. See, if these are some routers that are connected with each other, so you can say that for router X, router Y and Z are neighbors. And let's say this is connected to, so X is connected to these three routers as well. And let's say there is router A. And clearly we can see that Y and Z are neighbors or adjacent routers. But A could be also a adjacent router if this path, okay, this path, on this path we create a tunnel. So there are many technologies that are available which you can use and create a logical tunnel above a layer 3 architecture. And basically with that, you can say, or this router will feel that the next router or A is directly connected to it. So we can call it a logical adjacency, right? I hope that is clear. So because routers are basically repeating what their neighbors told them, right? So they are just repeating what the other router is telling. And that is why we call it routing by rumor as well. So router Y is telling X that I have this network and you can go to this network with this much amount of cost and this direction. But you do not really know if that the information that was provided by is by Y is correct or not. Right? You cannot prove it. You just have to accept it and use that route. Right? You can just compare it with other routes that are shared by other routers, and there is no other way to verify if it is correct or not. So that is why this process is sometimes called as routing by rumor. And that's the big picture of distance vector routing protocol. And now that we know what distance vector routing is, let's look at its some of the common characteristics or you know terminologies that appear very often. So a typical distance vector routing protocol works like this. So routers periodically send routing updates to all their neighbors or adjacent routers. And the key here is they don't just send a little piece of information, they actually broadcast their entire routing table. If it is not clear to you, let's break this down. Okay. So first thing that I said is periodic update. Okay. It is sending updates periodically. So periodic means update that are sent on a regular time interval. So there was a protocol, Apple Talks RTMP, which was a routing protocol that used to send updates every 10 seconds. So if there are few devices that are connected, let's say these are some devices that are connected with each other, they will be sending update about their routing every 10 seconds. It does not matter if there is any change or not. It will send this update every 10 seconds. So this router will send every 10 seconds. This will send every 10 seconds. And you can clearly see here that if some routing protocol which sends update at a frequency of 10 seconds, update per 10 seconds, then it is definitely going to congest the entire network because it is too much frequent, right? And on the other hand, there is Cisco's IGRP, which is a routing protocol which waits much longer, about 90 seconds. So see, Apple Talk waits for 10 seconds and Cisco IGRP waits much longer, which is around 90 seconds. And it matters a lot because if updates are sent too often, the network can get congested, as I told, and router waste too much of CPU for sending updates and again. And if updates are sent too rarely, not very frequent, meaning the routers are you know going to resolve the network or converge the network at very slow pace. So let's see if they're sending updates very slowly. So if let's say this is 90 second, okay, 90 second, it is going to send update at 90 second, again 90 second. uh, this router is sending update at 90 seconds, so every other router is going to send at 90 second. And let's say there is some computer maybe connected on this LAN and it wants to send some information to this PC, okay, and this by some malfunction got disconnected from this port, and it is going to send its update every 90 seconds, right? You understood that? So we don't know at what point of time this device got connected between every 90-second interval. So let's say if at t equals to 0 this device got disconnected and your router is going to send update after 90 seconds, it might get disconnected in between. But even with that condition, you can see that there is a huge amount of time that is between your update and this disconnection. So let's say after 45 seconds this device sends the update according to its 90-second regular time interval, and this device will get that information, and it is also going to wait for its update time interval, and it will share that with the next router. And the problem here is that your packet does not wait for the update interval, right? It is going to come here, and your router sees that, okay, this network is connected to this router, I'll share it through this path or this path, because it does not know that the PC or the LAN connection at this interface is disconnected, because it has not yet converged the entire scenario about the network. And that is why this problem occurs very often if the convergence time is too much, right? And this condition seems to be like a black hole, as you are sending your traffic but it is going nowhere, as the system was connected few seconds ago or maybe few minutes ago, and your router does not and your router has not yet converged it, right? So this is one of the important problems that we need to address, right? The second thing is neighbors. In a routing protocol, a neighbor is simply another router that shares a common link or a logical adjacency. I explained to you what logical adjacency mean. Okay. And distance vector protocols rely on neighbors to spread information. Each router sends its updates to its neighbors, and those neighbors pass the information along to their neighbors, and so on. It goes on. And that's why we say distance vector uses hop by hop updates. right? The updates are carried by routers and exchanging them with each other. We don't know what is happening on the other side of network. We just know what is shared by the adjacent router to us. So the knowledge spreads step by step, like passing a message down a line, right? Next thing is broadcast updates. Finally, how does a router announce itself? Okay, when it comes online, how will it tell others that I'm there, I'm using this routing protocol? The simplest method is to send updates to a broadcast address. Broadcast address means everyone, and in IP, a broadcast address is a broadcast address is 255 255 255.255. That means your router is going to send update out of each interface. And if the router adjacent to you is running the same routing protocol, it will receive that update and react to it, right? And if there is an end system, it will not reply to it and discard that packet. This is how things work. Okay, so this is a very basic example. Different routing protocols use their own way, their own algorithm to exchange messages. So routers running the same protocol will hear the broadcast and respond appropriately, and other devices like hosts that don't care about routing will just ignore and drop their packets, right? And this way routers can quickly discover each other and start sharing routes. I hope that is clear. So the recap is distance vector protocols send periodic updates. They rely on neighbors to pass information hop by hop, and they often use broadcast. Okay, not every routing protocol is going to use broadcast. There are different ways, but yes, they often use broadcast to announce themselves and find other routers. I hope that was clear. And in the next video, I'm going to explain to you what is routing by rumor. Okay, it is a famous terminology that people use when we talk about distance vector routing, right? And this I forgot about this slide. So some well-known distance vector protocols include these, and we know about the routing information protocol for IP networks. The below you can read for your information, but they're not that important. Okay, so this was it for this video. I hope it was helpful. If you have any doubt, you can comment down, and thank you so much.